All right, so we've previewed this topic of square roots, and I know it says when to use absolute value, but this is chapter 6, and it's about square roots. But let me go way back and really preview the idea of square roots. So if I say the square root of, let's say, 9, what you can think if you're really going back, I'm talking, the very beginning of how you might have learned about square roots. You can think of there's two balloons, and each balloon should get the same thing. In this case, each balloon should get a 3 because I want the two numbers I put here to multiply to be 9. So the answer would be 3. And I just wanted to bring that up because it gets a little trickier when we start using algebra. So let's say I said the cube root, well, this isn't algebra, but the cube root of -8. Well, because I said cube root, instead of 2 balloons, I'm going to have 3 balloons, and I want to fill those up. And negative, well, you have to think about it a little bit, but I think you'll get it. -2 times -2 times -2 will give you -8. And so this is one thing what you might have learned a long time ago, and that is negatives don't work for square roots. If I had a -9, I really wouldn't be able to fill the two balloons equally. So couldn't really get an answer, but with a +9, I get positive numbers. But with cube roots, I can. 3 negatives will give me -8. So that's one idea of this balloon drawing shortcut. But I also want to bring it up because let's say I had the square root of 16x to the, let's go 12. I drew my two balloons. Well, 16 is 4 times 4, but you notice I have 12 x's here, or 12 of a kind. In other words, you can think of this as 12 x's. So each balloon gets 6 of them. And so the correct answer would be 4x to the 6. So as childish as drawing these balloons is, it can help you with some fairly advanced questions. In other words, some students have a little trouble with why the 12 is a 6 over here. And some of the explanations are a little, certainly more involved than just drawing two balloons. But I just wanted you to be able to see that. All right, now I'm going to give an answer that's partially wrong right now. Let's say I said the square root of 25x to the 6. Now, if I write 5x cubed, that's actually not wrong on the face of it. You might think the answer should be 5x cubed. But here is the point of this video. The correct answer is 5 absolute value of x cubed. And that absolute value was not required in any other problem, but it was required here. So I'll go ahead and give you the quick answer as to when we need the absolute value, and then I'll explain why. So the reason why we need the absolute value is on this side of the equal sign, on the left side, I started with an even number, 6. And of course, on all of these, I started with an even number on both of these because it's an even number is the only thing you can really separate into two balloons. If I had 7, I would have a problem with that. But 6, I can put 3 here and 3 here. But I started even, and I finished odd. 3 is odd. 6 is even. Well, an even exponent will make negative things positive. What I mean by that is if I took a negative number, let's go way back to like an order of operations style question. If I said -2 to the 4th, which means -2 times -2 times -2 times -2. You notice I have 4 negatives, and anytime I have an even number of negatives, like 4 of them, the answer will be positive. So negative times negative is positive, negative, two more negatives will be positive. So if we have an even number, whether they're negative or positive, I'm not making a claim whether x is negative or positive. I'm just saying, just in case it's negative, I got to put these absolute values on it. All right. Back over here, it was correct not to have the absolute value because both of these are even. And you do not want to put or leave absolute values on an even number. These absolute values would be incorrect, and the computer would correctly mark it incorrect. So if you start even and finish odd, you need absolute value. So let me do an example where I put these together. Let's say I had the square root of 36, x to the 12, y to the 6. Now, we know how balloons work. Two balloons, each balloon, should I do it? Okay, I'll do it. Each balloon will get a 6 because 36 is 6 times 6. If there are 12 x's, I'll have 6 of them. And if there are 6 y's, I'll have 3 of them. Got a little sloppy down there, but I'll try to draw a little neater here. 6 x to the 6 y cubed. Now, do you see which single expression or which factor needs the absolute value? It's just this one, because that's the only one that started even and finished odd. So I chalk this up to respecting the equal sign. When we say something's equal, but one side has an even number that makes negative things positive, well, the other side is going to need something that makes negative things positive. Otherwise, they're not equal. So that's that idea. Now, to further complicate matters, the website, well, all homeworks, assignments at this level, sometimes give you an out. Sometimes they essentially say, we don't want absolute values. So if the problem says, assume all variables are positive, that's their way of saying, you know what, don't sweat this absolute value stuff. Leave the absolute values off, because we don't want to put absolute values on a positive variable. But if they say, assume all variables can be any real number, I'm going to say that there's a 100% chance that they want you to put an absolute value somewhere, because any real number means positive or negative, and they're trying to tell you, they're trying to give you a hint in the instructions that we want absolute value. All right, so hopefully it helps you get some of these numbers that we were talking about. You understand where all these numbers came from, but you also understand where the absolute value came from. So that's one of the problems that you'll see in Chapter 6, and it might come up even in other sections later.